Welcome to Data Structures and Algorithms. Today let's understand omega notation, written with the Greek symbol omega. You already know big O. It describes an upper bound on how an algorithm's work grows. Omega describes a lower bound. It tells us that an algorithm requires at least a certain rate of growth asymptotically. Imagine an algorithm that must examine every item in a list. If there are n items, it must perform at least n units of work. We can describe this lower bound as omega of n. As the input grows, the algorithm cannot do better than a linear amount of work for this problem. Think of it this way. Big O gives an upper bound while omega gives a lower bound. And here is an important distinction. Omega does not automatically mean best case. Omega is a mathematical lower bound while the best case describes a particular input scenario. For example, linear search can find an item immediately, but in the worst case, it may inspect every item. The correct omega bound depends on exactly what we are analyzing. So we have three important ideas: big O for an upper bound, omega for a lower bound, and theta for a tight bound. Remember, omega notation describes a lower bound on the asymptotic growth of an algorithm's resource uses. In the next episode, we'll learn about theta notation and what it means for an algorithm to have a tight bound.